Hi everyone, we are Team 4 and this is our project for SER502 Spring 2024. Hi, my name is Devjani.
I'm Kirtan Soni.
I'm Kalyani Joshi.
Lakshmi Kriti Hosmanikeshav Ram.
Let's get started with the presentation. Kruti, you get start with the slides.
Yeah. So in this presentation, we'll talk about our language, project pipeline, grammar, lexical analyzer and the parser, and some of the screenshots that was executed during the runtime. In this project, so our project is called as DEVLang. We have used Java Antler for programming our Lexa. For parser and evaluator, we have used Prolog. Parser is basically our intermediate code. And the sample code we have saved in a file with the extension of .dl.
Okay, so now I'll talk about our project's pipeline. So we have a basic script which has of extension .dl, and this script goes into a lexical analyzer which we have written in Java. This lexical analyzer generates a list of tokens in the terminal, and this list of tokens goes into the parser. And based on the list of tokens, this parser will generate a syntax tree, and the syntax tree will go into our execution engine. And out of that, we'll get the output for our language, DEVLang. So first we start with our grammar. So we wrote this grammar as a combination of parser, and this gives the output of a syntax tree. And we had divided this grammar in the traditional format of terminal and non-terminal, with features containing things like Boolean, conditional logic, logical comparison, integer comparison, etc.
So now we'll talk about the lexical analyzer and the parser. So our lexical analyzer takes input from a program file which has a .dl extension, and this DL stands for devlang, which is our language. And this tokenizer generates a list of tokens by removing the spaces, tabs, and new lines. Now this list of tokens which we get from the terminal are given as an input to the parser, and then parser takes this and then creates a parser tree by using our grammar, and this syntax tree is given as an input to our evaluator, which gives the final output of our language.
Okay, so now I'll pass my sharing to Kirtan, who will run our project in real time. Over to you, Kirtan.
Okay. Now let me share the screen for. I shared the wrong screen. Give me 1 second. Can you see the screen? Is the screen visible?
Yeah, we can see our GitHub repo screen.
All right. So I'll start with first the README, which has everything that is required for the language to run. It includes installation. So our language can be run right out of the box. You just have to git clone, and all the compiled classes are available in the GitHub repository. So as mentioned in our requirements of the project, we have added a bash script that will run our code as a pipeline. So you don't have to run anything except for the bash script, which is right here. And we have also given the explanation of how it should be run, what is the usage of these commands in the README. If you want to also build the compiler locally, there is a instruction given for building the lexer. And there is also instructions for the compiler and the executioner code. All right. So I'll start with the example code. We'll start with the first generic code for all languages, which is hello world. In our language, the language starts with dev and ends with lang, and everything in the middle is ran. It is a procedural language, so everything is going to run from top to bottom. This statement is the terminal out statement, and which will print all of the data that is given inside this terminal in this out statement. And we support data types in this terminal out statement. So when we want to print a string, we ask the terminal out statement to print a character array of hello world. And let's run this and see how it works. So I'll first run the bash script, and then I will just call the file name, and it will print hello world in the terminal. And now let's see other features of this language. So first of all, this language supports assignment operations in multiple types. You can assign a string in such a way where you have to define the type after the assignment operator and right before the literal. This makes sure that the type binding is hard on right on the variable, and there is no requirement in the declaration of the variable. And Boolean type is treated this way, where bool is the keyword used and true or false is the statements allowed in the keyword. You can also use integers here in this way, or you could integers are replaceable by arithmetic expressions, which anyways return integer data types. So you can directly add a arithmetic operation to assignment statement where it's gonna return 11. It will store x as 11, and then we will again change the x value to 5 minus itself, where it also supports variable in arithmetic operations. And all of these are examples of printing the data. Now let's run this code. And as you can see, 5 minus 11 is 6 minus 6, and it prints minus 6. X, and then B is true, so it prints true. String is hello, so everything works correctly. All right, so let's move on to Boolean expressions. Boolean expressions are supports generic Boolean expressions such as AND gates, OR gates, NOT gates, and it also supports integer comparison as a Boolean expression. Boolean expressions are replaceable by a Boolean data type. So instead of writing this, you could write just a Boolean bool true. So it will just print out true. It is exactly replaceable. And let us see the output for these. As you can see, AND of true and false is false, and true is true. And false and false, or for false and false is false, and true with anything is true. And you can see that all of these are in the correct order of their logic according to these statements. So I'll move on to the next statement, which is arithmetic statements. Our compiler can support up to 4 arithmetic operations, and we'll perform these four arithmetic operations on 2 different variables. And as you can see, all of these return the correct values. Now let's move on to if-else statement. There are 2 kinds of if-else statement that our compiler supports. One is the generic if-else, which has keywords if and otherwise with the curly brackets as their runtime. As their statement blocks. And there is another type of if-else, which is ternary if-else, where you can just provide a question mark and then a condition, which will be followed by a first condition being, if the condition is true, then then run this, otherwise, and then there is a colon, and otherwise run this other thing. So as you can see, 3 is equal to 3, so it should be printing a hello. I'll also move on to the next statements, and then I'll print all of them together. Let's start with loops. So in loops, there are three types of statements, three types of loops that are supported. One is the range loop, where you just have to assign a variable with a value and then define what its end value will be. And this loop will run till after, like, it'll increment x by 1 and it'll run till the range is satisfied. There is a while loop which only requires a conditional statement, and you can just run this loop with over and over again, over and over, and it will basically run till the condition is true, which is normal while loop. And there is another for loop where you just assign, there is an assignment statement, and then there is a conditional checking. And then for this file name, increment is supported right inside the braces. And I'll also show how we can also process null statements in our code, where if you want the compiler to do nothing at a particular interval, you just have to provide us colon to do with it. All right, I will run all of these statements to prove that everything works fine. These are loops. These are if else. And these are null statements. I will also show you the folder directory of the project. Our example codes are saved under data, the documentation related stuff, and the explanation of the compiler is saved under docs. You can see the source code in the source files, where Lexer folder contains all the Lexer related files, which are Java files, because our Lexer is made in Antler. The compiled classes will be available right inside classes, and this is why our code runs right out of the box. The parser is in Prolog, and this is the parser which contains all the grammar for generating a parse tree, and the interpreter is the one that evaluates, which is also written in Prolog, which will generate output. And this is the shell script which will run the tokenizer and then generate a parse tree from the parser, and then run the interpreter and echo the result in one pipeline. All right, that is the end of our presentation, and thank you for listening.